Pluto is a distant and unpretentious, seriously honest planet that was once a part of our nearby planetary system. However, advancing, concerning statements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight. They suggested that this far-off world is on a potential collision course with Neptune. But how could this truly happen? Likewise, what might be the consequences of such a massive event? Are we witnessing a confusing cosmic anomaly? Or is there more to this impending disaster? Join us as we examine the scientific implications of a potential Pluto-Neptune impact. Pluto, a former planet that was reclassified as a dwarf planet, remains a subject of interest in the vast universe. According to recent hypotheses by leading experts, Pluto's orbit is perilously close to Neptune's. Astrophysicists Neil deGrasse Tyson and Michio Kaku are raising the alarm about a potentially catastrophic collision between these two planets, which could have significant consequences for Earth. But how is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It takes a staggering 248 years to complete a single orbit. Since its discovery in 1930, it hasn't even completed one full revolution. However, the intrigue doesn't stop there. Pluto's orbit is characterized by its highly elliptical shape, deviating significantly from the nearly circular orbits of the major planets. What makes Pluto's orbit even more remarkable is its inclination, which is tilted 17 degrees to the ecliptic plane. This unique trajectory adds layers of complexity to its orbital dynamics. Perhaps one of the most fascinating aspects of Pluto's orbit is its interaction with Neptune's. For nearly 20 years in each orbit, Pluto comes closer to the Sun than Neptune, defying what we might expect from their positions in the solar system. This raises the obvious question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began shortly after its discovery. Initially, astronomers struggled to understand its unique path. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto stands out due to its steep inclination and irregular shape. The mystery deepened with the realization that Pluto's orbit does, in fact, cross Neptune's. The stability of Pluto's orbit, despite these complications, is evidence of the intricacies of celestial mechanics. The three-body problem in space. Determining how three objects like Pluto, Neptune, and the Sun move and influence each other with their gravity plays a crucial role here. It's like predicting their future positions based on their initial states and gravitational pulls. In Pluto's case, this problem highlights how its orbit, Neptune's orbit, and the Sun's gravity work together in a complex manner. Terms like non-synchronous libration, orbital precession, and VZK wobbling are key to understanding this interaction, as explained by astrophysicists. What keeps all planets in their orbits is non-synchronous libration. For Pluto and Neptune, this term essentially means that when Pluto crosses Neptune's orbit, it is positioned at least 90 degrees away from Neptune. This spatial separation is crucial in preventing their orbits from intersecting. Orbital precession, on the other hand, refers to the vertical motion of a body in its orbit. For Pluto, this means that when it comes closest to Neptune or other giant planets, it is positioned far above their orbital plane, adding an extra layer of safety from potential collisions. Another key factor in this situation is the VZK wobbling, named after three scientists, Zell, Kai, and Kaku, who studied how objects move in space. It involves how three celestial bodies like Pluto, Neptune, and the Sun exert gravitational pulls on one another. This tugging influences their movements. In Pluto's case, the VZK wobbling helps explain why its orbit near the Sun is so erratic. Despite Pluto's orbit appearing chaotic, this wobbling helps maintain its stability over long periods. The VZK wobbling shows that even though space seems wild and unpredictable, there are patterns and rules that maintain some order. These forces help keep Pluto's orbit stable, ensuring it doesn't collide with Neptune or drift off course. This three-body problem is vital to understanding how orbits change due to gravitational interactions. Studying this helps us learn more about Pluto, our solar system, and even distant galaxies and their stars. Numerical simulations conducted in the late 1980s revealed that, despite stabilizing properties, Pluto's orbit is highly sensitive. Minor deviations in initial conditions can lead to significant changes over time. However, these characteristics of Pluto's orbit have been found to maintain stability over extraordinarily long periods. Monitoring the perturbations caused by later automated assessments has helped scientists understand how the giant planets, like Neptune, Jupiter, and Saturn, influence Pluto's orbit around the Sun. Neptune shares a unique relationship with Pluto, where for every 2 orbits Pluto completes around the Sun, Neptune completes 3. This resonance helps keep Pluto's orbit stable. However, Neptune isn't the only player at work. Jupiter's gravity also plays a significant role in stabilizing Pluto's orbit. Saturn contributes as well. Studies show that Jupiter's massive gravity is strong enough to ensure Pluto stays on a consistent path for millions, possibly even billions of years. It seems Neptune, Jupiter, and Saturn work together to ensure Pluto continues to move safely through space without encountering trouble. These orbital peculiarities are crucial for maintaining stability in the solar system. Without these dynamics, the solar system as we know it would be far more chaotic. Bodies like Pluto could collide with others or be ejected from their orbits, triggering a chain reaction with other celestial objects. For Pluto, especially with concerns about a potential collision with Neptune in the future, understanding its orbit is essential. This provides a clearer picture of the dynamic nature of our nearby solar system. The case of Pluto demonstrates that even the most seemingly unstable orbits can achieve a state of balance through the complex interplay of celestial forces. Of gravitational powers and orbital mechanics, it likewise features the significance of consistent perception and examination of these eccentricities to more readily comprehend our place in the universe. Exploring the profundity of space frequently compels us to confront the uncommon nature of celestial bodies. In addition, Pluto's orbit is an ideal illustration of this peculiarity. The idea of orbital turmoil, which alludes to the delicate dependence of a celestial body's orbit on its initial conditions, is plainly shown. For Pluto, this implies that even slight changes in the dwarf planet's position or speed can significantly alter its long-term orbit. Utilizing computerized simulations has been immensely useful for researchers in understanding how Pluto moves in space. These simulations utilize complex mathematics to model how Pluto and other space objects, like Neptune, exert gravitational pulls on one another. By tweaking small details in the simulations, space researchers can observe how even minute changes can result in significant differences in Pluto's eventual position. In the late 1980s, these simulations revealed something intriguing about Pluto's orbit. Despite having features like non-synchronous libration and orbital precession to keep it stable, its orbit can still be inconsistent and strange. If you start with even a small difference in Pluto's initial position or speed, its orbit could end up looking entirely different after just a few years. Yet, despite this chaos, Pluto's orbit remains stable over vast timescales, such as billions of years. This means that Pluto's journey around the Sun has a kind of order to it, even though it initially appears chaotic. Predicting celestial movements, especially when they involve irregular orbits like Pluto's, is a significant challenge. The inherent unpredictability of these systems means that long-term predictions are often fraught with uncertainties. While mathematical models provide excellent tools for understanding and forecasting the future movements of celestial bodies, they also highlight the limitations of our predictive capabilities. These models heavily depend on the accuracy of initial conditions, and even the slightest error or distortion can lead to vastly different outcomes, making precise predictions an arduous task. Beyond the chaotic nature of planetary orbits, Pluto reminds us of the ever-changing and dynamic nature of the universe. While we've made immense progress in understanding space, Pluto's case serves as a reminder of how much of the universe remains a mystery. Grasping the gravitational effects of the giant planets on Pluto's orbit provides significant insights into the broader dynamics of the solar system. It demonstrates how the presence and position of each planet can profoundly influence the stability and trajectory of other bodies within the system. So why are leading astrophysicists recently raising concerns about a potential collision between Pluto and Neptune, despite all these intricate forces working to prevent such an event? Neil deGrasse Tyson, a prominent astrophysicist and a significant figure in advancing cosmology, offers a unique perspective on the mysteries of our solar system, particularly the fascinating case of Pluto. Tyson, known for his role in reclassifying Pluto from a planet to a dwarf planet, provides insightful analysis on the evolving nature of celestial mechanics and the public's interest in the overlooked corners of space. Tyson's stance on Pluto's reclassification is based on the ever-developing understanding of our solar system. He views the reclassification not as a diminishment but rather as an important adjustment to our growing comprehension of the diverse bodies orbiting our Sun. Tyson's approach to celestial mechanics is one of continuous learning and adaptation. He sees the complexities of orbits like Pluto's as a reminder of how much there is still to discover in space. This fascination with these questions keeps the study of space so exciting. However, despite Tyson's optimism, his thoughts on Pluto's potential collision with Neptune paint a different picture. His concerns about Pluto's fate, once a planet, stem from his understanding of the unpredictable nature of these orbits. Tyson acknowledges that while Pluto's orbit has remained stable so far, small shifts over time could lead to catastrophic events. Pluto's path, particularly its interaction with Neptune's orbit, is a delicate cosmic dance that might not remain steady forever. In Tyson's view, even small perturbations in Pluto's orbit could have significant long-term effects, and if these shifts accumulate over millions of years, they could eventually result in a more erratic outcome, possibly even a collision with Neptune. However, these events wouldn't occur anytime soon. Rather, they would unfold over long stretches of time, beyond human lifetimes. Nevertheless, Tyson's cautionary stance underscores the importance of continued observation and understanding of Pluto's orbital dynamics. Tyson is not alone in his views. Michio Kaku, a theoretical physicist, also speculates on the potential chaos that could arise from planetary interactions within the solar system. While Kaku shares Tyson's enthusiasm for exploring the wonders of the universe, he also recognizes the inherent instability of planetary orbits and the unpredictable effects that could emerge over time. Both Kaku and Tyson emphasize the importance of ongoing research into the forces governing planetary motion and the future of our solar system. Ultimately, the case of Pluto serves as a reminder that our understanding of the universe is continually evolving, and new discoveries often lead to more questions than answers. As astronomy continues to develop, the possibility of an event like a Pluto-Neptune collision reminds us that space is full of surprises and that the seemingly tranquil orbits of planets can be subject to dramatic changes in the future. These reflections on Pluto remind us of the importance of keeping our eyes trained on the stars and our minds open to the mysteries that still lie ahead.